Hi, we're back. Our assistant was a little upset that she missed out on the first part of the lecture, so now she's here to talk to you a little bit, and I am here to talk to you a little bit about some examples of using natural log and finding derivatives of functions that have natural log involved. So our first example that we're going to look at is f of x equals x cubed times the natural log of x. And so our job in all of these examples is going to be to find the derivative of this function. And when I read this function, f of x equals x cubed times natural log of x, I hear the word times, and that immediately makes me want to think about the product rule. So I want to use the product rule because we have a first function times a second function. Okay, so now is the time for you to think about, all right, what is the product rule? Product rule is first times derivative of the second plus second times derivative of the first. Okay, so for us, that means we have first, which is x cubed, or x to the third, times the derivative of the second. And our second function is natural log of x, and our derivative of natural log of x is 1 over x. That's just what its derivative is. As soon as you want to write down the derivative of natural log of x, you write down 1 over x. Okay, so we have first times derivative of the second plus second, which is natural log of x, times the derivative of the first. And our first function is x to the third, so its derivative is 3x squared. So we've written down our derivative, and we're done. Okay. If you were super excited about cleaning this up, and again, most of the time you're not going to want to clean these up, but if you were, x to the third times 1 over x, one of those x's will cancel and you're left with x squared. And then this second part, you can leave the second part just as it is, but a lot of people will write the 3x squared first and then times natural log of x. So this is cleaned up, but you don't have to clean it up. All right, let's look at another example. Our second example, we have f of x is natural log of x all raised to the 5th power. Okay, so when I look at this function, what I see is that I have an inside function, which is our natural log of x, and I have an outside function, and the outside function is that 5th power that's hugging the natural log of x function. So the outside function is u to the 5th. So this guy right here that I want to think about using the chain rule to find this derivative. Okay, so the chain rule says take derivative of the outside, keeping the inside the same, times the derivative of the inside. So I might want to do some work on the side, and you don't have to. This work on the side, after you've done about 500 chain rule derivatives, you might not even write all this stuff on the side. But our derivative of the inside, the derivative of natural log of x, is 1 over x. And the derivative of the outside, the derivative of u to the 5th, is 5u to the 4th. Okay, so our chain rule says take the derivative of the outside, keeping the inside the same, so that's 5, u, which is natural log of x, to the 4th, derivative of the outside, keeping the inside the same, times the derivative of the inside, and the derivative of the inside is 1 over x. So there's our final answer. Okay, so we used the chain rule on that example where our inside function was natural log of x. Here's a slightly different example. F of x is equal to natural log of... I know this can be upsetting sometimes, but we're going to try and work through it. Okay, so our function is f of x equals natural log of x squared minus 8x. Okay. And here this is a little bit different because here I have natural log of something fancier than just an x. Okay, so this is natural log of some fancy stuff. This fancy stuff is kind of like an inside. And so when we have natural log of fancy stuff, we need to apply a chain rule to the natural log function. And this is how that chain rule for natural log works. So when we have natural log of stuff, where that stuff is fancier than just an x, so in this case like an x squared minus 8x, when we have stuff in there that's fancier than just an x, then if f of x is equal to natural log of fancy stuff, then our derivative is 1 over the fancy stuff times the derivative of that fancy stuff. Okay. Now, you have a choice. You can either kind of memorize this as our natural log derivative rule for natural log of fancy stuff, or you can kind of see that this is actually the chain rule. Derivative of the outside, keeping the inside the same, times the derivative of the inside. Okay, so back to our example. In our example, we have natural log of fancy stuff. So our derivative, f prime of x, is going to be 1 over the fancy stuff, so 1 over x squared minus 8x, times the derivative of the fancy stuff, so times 2x minus 8. And there's our final answer. If you're upset with that final answer, like Ariana is a little bit, then you can clean it up. And the way that you clean this up is this times 2x minus 8. You can write that on the top of the fraction. So another way to write this is 2x minus 8 over x squared minus 8x. Okay, let's look at one final example. One final natural log example. And in this example, we have y is equal to 75 plus 3 times the natural log of 5x minus 9. And you might notice that this example looks kind of like one of your remote assignment examples that you're asked to look at. The numbers are different, but it's a similar kind of setup. So when we take the derivative of this function, the first thing I notice is I have a plus sign, which means that I can take the derivative of this first function, write down the plus sign, take the derivative of the second function. Okay, so that's what we're going to do. The derivative of 75 is a constant, so its derivative is 0. I don't even have to write that down if I don't want to. And then we have 3 times the natural log of fancy stuff. This fancy stuff is our fancy stuff inside the parentheses. Okay, so we carry along the number in front. We carry along the number in front times 1 over the fancy stuff times the derivative of the fancy stuff. Okay, so that can be a final answer, and we're going to see if I can clean it up a little bit. So one way we can clean this up is get rid of the 0, take the 3 times the 5, gives us 15, and keep the 5x minus 9 in the denominator. Okay, so those last two were kind of rough, but I hope you could hear what was going on, and we'll be back in a bit. Thanks.